Hello everyone, and welcome to this PIR live event brought to you by Partners in Research. My name is Stacey Joyce. I'm the VROC Program Manager at Partners in Research and your host for today. I'd like to welcome Dr. Gamon, who is an AITF Chair and Professor in both the Departments of Biology and Earth and Atmospheric Sciences at the University of Alberta. Thank you so much for joining us today, Dr. Gamon.
Well, thank you. It's a pleasure to be here and see all the faces out there. Hello, everybody.
Hello.
Hi. And joining us today in the video conference. Please say hello and give us a wave when I introduce you. We've got Mr. Shingles grade 11 students at Centennial CBI in Guelph, Ontario. Hello, everyone in Guelph. And we've also got Mr. Robinson's grade 7 students at Exarnate Middle School in Iqaluit, Nunavut. Hello, everyone in Iqaluit.
Hi.
And finally, I'd also like to welcome all the students who are joining us today by watching the live stream. Post your questions on Twitter using the hashtag AskPIR. And if you have space, include your name and your school name or city so we can give you a bit of a shout out when we ask your question. So Dr. Gamon, let's start off with a little bit of information from you. You describe your area of expertise as the breathing of the planet. Can you describe what that means and what motivates your research in this area? I see you've got some slides to show us as well.
Okay. The breathing of the planet is something that happens every day. You don't think about it. You know, we think about ourselves breathing, and we know when we're breathing, and we can feel that. But the breathing of the planet is invisible, and we can't see it. So we may not know that it's happening. But every time, you know, the wind blows, and I have this picture of wind, it kind of reminds us that the air is moving. And with the movement of the air, the plants and all the animals and all the ecosystems of the planet are exchanging gases with the atmosphere, taking up CO2 or releasing CO2, carbon dioxide, through processes of photosynthesis and respiration. So even though it's invisible, every time the wind blows, it kind of reminds us that the planet is breathing. And we can use that to actually measure the breathing of the planet, as shown in this picture. I'm going to go to the next picture. You know, one way we can do this is to put a leaf in a chamber, and we can measure the photosynthesis of that leaf. But the problem with that is it doesn't tell us anything about the whole ecosystem. It just tells us about that one tiny little spot. So we can use the other method shown with the tower, which measures breathing of larger areas, and that measures the exchange of CO2, photosynthesis and respiration. And so that's how we can measure the breathing at a larger scale. And the reason why we might want to do this is just so we can know the health of the planet, but we can also see how things are changing with stress, drought, or climate change. We might want to know, how is the world changing and how is the breathing changing? That gives us an indicator of the condition of the planet. So this method here, it's called the eddy covariance method, is a way that we can use the wind in exchange of gases, and this is one way to measure the breathing. And something we can't see, but we can measure it with instruments. Now, this is a complicated picture, but what it tells you is you can use all kinds of other methods like satellites and airplanes to measure the whole world, and we get pictures of the whole world, like you see in the upper left-hand corner, and that from that we can tell how much we can tell the photosynthetic rates, the activity, the breathing of different parts of the Earth. And that, how do we do that? Well, we do that by comparing satellites to imagery from aircraft to things that we measure on the ground. So what you see in the bottom left-hand corner is the breathing measured from the eddy covariance, that little tower in the picture, and from a little robotic cart. And the little robotic cart has an instrument just like the satellites, and it's measuring the color of the landscape, just like in the pictures, but for a particular spot. And we can compare this over time, and we can see that the breathing is slowing down in this particular landscape over 3 years. And this is because we're looking at California under a drought, and in a drought, the photo and in fact this is an ecosystem that's dying under drought, and we can see the breathing slow down each year using these methods. This is the robotic cart that we use, and we can measure surface properties. Just like from a satellite, we can look at the surface of the Earth. Well, this little cart can ride across a landscape and measure the surface on the ground, so we know what we're looking at, and we can use this to calibrate our satellite data. And here's a picture of some of my students setting up the robotic cart out in a field. This is in an agricultural field. Oh, by the way, this picture here is the landscape after it got dry and it burned, and then it's growing back. So we can see the landscape changing, and the breathing changes as it changes. And in this picture here, my students are putting the cart out in a alfalfa field, and they're measuring the breathing of a crop. And in the background are some of the other instruments that we use. And the reason why we use these carts a lot is because it measures the same way that a satellite measures, and we want to have those measurements on the ground. So why don't we just use the eddy covariance, the tower methods? Well, one reason is it's very expensive in southern Alberta, and it costs about $50,000 to put in one of those towers. But we can put in other kinds of sensors, optical sensors that look at the ground and can tell us something about the breathing, and they're much cheaper. So we're trying to compare different sensors and measure the breathing different ways. And the next slide shows you sort of how we do this. We take the satellite data, we take measurements on the ground using optical measurements, and we actually measure how much the vegetation has grown through photosynthesis, and we can measure the biomass that way, and we can compare all these different methods to think it's telling us. And I think what I'll do is just skip over the next slide a little bit. And I want to take you to a place I've been called Barrow, Alaska. This is the northernmost tip of Alaska, the Arctic tundra. And it reminds me why I'm interested in these kinds of questions. Because as we know, the world changes, and the world is warming in the north. And what this is doing in Alaska is the sea ice is melting, and so there's more waves along the coast. The permafrost is also melting. And so you can see the coast of this town eroding away as the waves wash away more and more of the town every year. It's washing away about 10 meters of the coastline here every year from the melting of the permafrost and the melting of the sea ice and the waves. And the interesting thing about this picture is it reminds me people lived here hundreds and hundreds and thousands of years ago even. You can see the whalebone rafters of an old house that are washing out as the permafrost melts away. And sometimes people, bodies wash out because the challenge and problem for the people who live there to try and preserve their history. But the other interesting question is, how is this melting and changing affecting the breathing of the tundra, the photosynthesis and the respiration? One idea is as the landscape melts, more respiration, carbon will be coming out of the soils, and that will speed up climate change because that's warming the atmosphere. The other idea is, well, maybe the plants will grow more and the breathing will change in a different way. Photosynthesis will increase, and that will take up carbon dioxide. And so there's reasons why we're interested in places like the north because they're changing so fast. So we're interested in understanding how change and disturbance affects the breathing, and we do that by measuring photosynthesis and respiration in all sorts of places using these methods. So that's all I'll say for an introduction, and let you guys ask me questions.
That was great. Thanks, Dr. Gamon. I think let's start with Mr. Robinson's class at Exarnate Middle School in Iqaluit, who has a question all the way from. And Dr. Gamon, if you could close your slide presentation, we'll be able to see you a little bit better as well.
Okay.
Do we have a question from our grade 7 class?
Anyone? Did you have a question? No? I think they're still digesting a little bit.
Let's move over to Mr. Shingles' class in Guelph, and we'll come back to you guys in Iqaluit. I'll give you a minute to think of something great. How about Mr. Shingles' class?
Sorry. Okay, I can see now. Okay. We were wondering, when did you decide that you wanted to start working with the environment?
That's really good. I think it was pretty late in life for me because I actually got pretty tired of science in school and college. I took science classes, but what really got me excited was after college, I got to work with a scientist, and these were a group of scientists at a place called Carnegie Institution, and I had so much fun doing what we did every day. It was creative, it was exciting. Every day I was eager to go in to do my job, and I had no idea you could have so much fun doing a job like that. And I thought, well, why didn't anybody tell me this in high school and college? And I guess the field I was studying hadn't even been invented in high school and college. So like a lot of the stuff I'm showing you here, I didn't even know that stuff was going to exist. So even though I was interested in the environment all my life, I enjoyed being outdoors, I enjoyed plants and animals and the outdoors. I didn't think of it as something I was going to actually do as a job until I got to do it by luck after college. I just fell into it. It was so exciting that I said, I have to keep doing this. I've got to do science. And I went back to college to get a PhD degree at that point and continued. I've been doing science ever since. So I hope some of you out there, who are interested in science, if you feel that you're interested, I hope you find a way to do it because it's really a lot of fun. It's one of the most satisfying jobs and careers you can have.
Great. And I think it must be the same now that, the careers that will be around in 5 to 10 years, everything is changing so quickly. So let's check.
Yeah, you never know.
Ahead.
You never know what the future will hold. So, get a good education and learn about everything you can. And then, you might just fall into a really good opportunity. And that's how I did it. But.
Excellent. So let's try going back to our grade 7s in Mr. Robinson's class in Iqaluit. Has anyone come up with a question? I know you've been studying more in the area of plants and photosynthesis, maybe.
Okay, guys, any questions? Have you thought of any?
No.
I had one question myself. Is that you were saying the coastline in Alaska is eroding by 10 meters a year. Is that true all over the Arctic?
It's true in many coastal areas of the Arctic. Not all areas, but areas that have sort of peat soils with permafrost. As the sea ice diminishes and the storms increase of action on the coast is leading to tremendous rates of erosion in parts of the Arctic, certainly in parts of Alaska. That's true. There are other areas that are just like that, and whole communities are having to move as a result because their towns are washing away.
Wow. So, Mr. Robinson's class, maybe we can ask you a question. Do you see in your community any of these changes happening with reduced permafrost or any erosion of the shoreline near?
Have you guys noticed any of those changes? Changes in the coastline around here?
No.
What about changes in permafrost? Yeah, what have you seen? So you have seen some changes? Amber? Permafrost is the frozen ground, like beneath the surface. Yeah?
can actually discuss what permafrost is.
Jeff?
There's more plants growing.
There's more plants growing? That's a good observation. We're certain. Yeah, we're seeing some new plants moving in, and other plants that are growing taller. And Simon just mentioned some birds that we've never really seen in these parts before.
That's very interesting. Thank you for letting us know, because you're very far away from me anyway, as I'm in near Toronto, Ontario. Dr. Gamon, did you have a comment?
I have a question for the class in Iqaluit, whether any of your parents or grandparents notice changes when you talk to them. Do they talk about how the tundra or the area around you has changed? Sometimes people who've lived a long time can notice these changes, because they're sort of slow sometimes. They take a long time.
That's a great question. Did you guys all hear it?
Yeah.
So have any of your grandparents or parents talked about that?
Yeah.
Yeah, what if they said, can you say that a little louder? No? Okay, Josie's feeling a little shy, but he says that his grandparents are noticing the permafrost is melting. Jeff? You're going to have to say it louder. There's trees growing near Kimirut now? Okay, so Kimirut is a community that's fairly close to us. It's about a half-hour flight, I think, south of here, and they're saying there's trees starting to grow there.
Wow.
Kirsten.
That's
Well,
a big
thank you very
change.
much. Yeah.
Yeah.
Let's
They're also
take a
noticing
question.
glaciers.
Sorry.
Sorry.
Let's take a question from. How does a forest fire hurt or help the ecosystem? And does climate change cause more forest fires? For Dr. Gamon.
Okay, well, I'll answer the second part of that question first. Does climate change cause more forest fires? We think that the current climate change that we're experiencing parts of the world is causing more forest fires. And a good example is the Western North America, Canada, and the United States. California, for example, is experiencing more forest. What I showed you was a fire in a chaparral. And the fire changes the breathing, it removes the vegetation, and it causes lots of carbon to go back into the air, and that tends to speed up climate change. On the other hand, after the fire passes through and the plants start to regrow, the ecosystem starts to recover. If there's moisture and it can regrow, then the photosynthetic rate increases, and what we see after a fire is a recovery and moving back to something that was very much before. In most cases, that's called the succession process. You might know that term. And what isn't clear with current patterns of weather and is whether they're temporary or parts of long-term patterns. For example, there's a very long-term drought now in the western United States. And if it stays dry after a fire, plants won't regrow in the same way, and because the rains aren't coming back. So what we don't know yet is whether those kinds of drought are going to change the trajectory, the direction of succession after a fire. Idea is that, the ecosystem comes back to the way it was and regrows, and photosynthesis comes back, and the same plants come back over time, but we may not be seeing that in a changing world. We may see new plants moving in, kind of like we heard trees moving into the Arctic, and that's a sign something more fundamental is changing in our climate system and our Earth system.
Well, thank you. Let's go back to Mr. Shingles' class in Guelph. Does someone have a question from Centennial CVI?
Our question is, what is the worst cause of water pollution? Thank you.
I'm not sure I heard that correctly. What is the worst of water pollution? Or?
The worst cause.
The worst cause of water pollution. That's a really interesting question. I guess it depends on your perspective and where you are. But I'd say for the world as a whole, pollution is the use of fertilizer and fossil fuels, which cause nitrogen to get into the water and also phosphorus to get into the water. And phosphorus and nitrogen are important nutrients, but when too much of that gets into the water for lakes and streams, it causes algal blooms that can be quite toxic and dangerous. And when those algal blooms happen in the ocean, for example, the Mississippi River that drains into the ocean, into the Gulf of Mexico, it kills the fish in the Gulf of Mexico. It tends to create toxins that are toxic to people and animals and fish, but also it draws down the water, the oxygen in the water, which kills fish. So I'd say one of the big problems with water pollution is the amount of nitrogen and phosphorus that's getting into the water around the world because of human activity, fertilizers, and we mobilize nitrogen through burning fossil fuels, and all that nitrogen ends up in the water eventually. Everything sort of ends up in the water, so what we do ends up there. So there's local problems that are far more severe. The world as a whole, I would guess maybe nitrogen mobilization is the biggest one.
Excellent. Thank you. I think we spent some time talking with our grade 7s in XR8. Maybe we can go for another question right now from Mr. Shingles' class in Guelph.
Our next question is regarding climate change. It's how will climate change affect Canada as a whole, and how long do we have before it affects Canada?
Sorry, so you asked how will climate change affect Canada, and what was the second part?
It was how long do we have before we're affected drastically?
Thank you.
That's an interesting question, and that's one of the questions that motivates me in the work that I do, because I have the same question, and we're beginning to get some answers. So how is it going to the whole? I think we're already seeing climate change affecting Canada. The signs are there, particularly in the western boreal forest. We're seeing more drought, warming, beetle infestations, and fire. And it seems that that could be the result of climate change, of warming over a long time. So it could be we're seeing more fires in the western part of Canada, and that's one result of climate change. We're also seeing trees moving north, and trees have been moving north since the last ice age, so that's not necessarily new, but maybe the rate of change is the fact they're moving north is a sign that climate change has always been with us, but it's maybe speeding up due to human activity. So I think, the worst, climate change can be good and bad, but maybe one of the worst things is the fact that it sometimes catches us by surprise. We're not expecting things to change, and when we have sudden change, it could surprise us. For example, the forestry industry might suffer, or agricultural industry might suffer or benefit, depending on where you are. And it looks like Canada may have problems from climate change. And in the north, parts of Alaska, I told you, and parts of Arctic Canada are warming, and that's changing the permafrost. So it's going to be harder to build structures and roads, and it creates some challenges for the communities that live there, and all kinds of other things. So I'd say climate change is with us. How soon will it really be here in a big way depends so much on what we do, choices we make as in our societies. If we keep on burning fossil fuels at the rate that we're doing it, or speed that up, which we're doing, I think we'll have very, very pronounced and serious climate change in your lifetimes. It'll be change that would be both good and bad, depending on where you are. If, on the other hand, we manage to get in regulations or policies or an economic policy that encourages alternatives to so much fossil fuel burning, then I think that we could effectively slow that down and manage it. People are talking about not whether it's happening or not, or when it's happening, but now that it is happening, how can we slow it down and manage it and adapt to the climate change and keep it from being so fast that we can't adjust very well?
That's great. Good question. I think a lot of people watching probably had that same question. So we've got a few minutes left. At this time, I just wanted to ask you, Dr. Gamon, if you wanted to speak a little bit about maybe the applications of your research. So what implications do you have on any areas of our society or economics? And maybe even some parting words, if you have any words of wisdom for our young scientists or anything like that before we sign off today.
Sure. Well, I hope that there are some young scientists out there, because it's, I look at you guys out there, and we need scientists. Science is, as I said, I think the most fun thing you can do with your life. Scientists are really happy in their careers, so I would encourage you to consider science. And you don't have to be a scientist. So you can be an English major, you can be a history major and become a scientist. But the point is, do whatever you do, and if you enjoy it, find a way to do it. In terms of practical applications, there's lots of things that we try and do. At the same time that we're measuring the breathing of the Earth, we're also looking at what's growing where and the biodiversity of the landscapes. And so what we're trying to do is develop new ways of monitoring biodiversity, so that as the world changes, we can preserve biodiversity better by using satellite data and aircraft data to tell us where the diverse regions are and maybe protect those areas better. So one of the problems is we're losing biodiversity, and so managers need to know, how do we manage the land, parks, and other things to maintain biodiversity? So maybe we can help with that problem. In terms of the breathing of the Earth, the processes we measure can really help tell us about the health of an ecosystem. For example, if you're a farmer, we can tell you a lot about the health of your crop and whether it needs more, just not adding any more nutrients and avoiding that water pollution. And so by getting the kind of information over large areas that can tell us how farms and rangelands like cattle grazing areas are doing and the productivity of those areas, we can help guide the management and tell people what they're doing is good and what could be maybe improved, or where we can minimize the use of fertilizers and things like that to get a certain yield of a crop. Because all this breathing turns into crop growth and plant growth. So we could help the forestry industry, help them forest yield and forest production. I also imagine a future world where we might be measuring carbon everywhere all the time. Just like right now we have an economy that measures money, and we know how much money gets exchanged in the economy. We can keep a budget of money exchange. I envision a world where we keep a carbon budget, and we measure the carbon, the breathing of the Earth everywhere, and we use that to reward people and countries that do a good job of maintaining the absorption of carbon through photosynthesis. For example, if a country has a rainforest and they protect the biodiversity and the photosynthesis, that's good for the planet because it takes up carbon and keeps the climate stable. If a rancher manages his or her land very well and keeps it healthy, and that takes up carbon and puts that carbon in the soil, we can reward those ranchers by paying them to store that carbon. So I think there's practical things we can do in the future that haven't even been invented, like a carbon market. And that's something I'm trying to tell other people. And I don't know if it'll happen, but if it happens, I think that could have all kinds of benefits. And there's also other things as well, but maybe I'll stop with that. And, you know, we don't know what the future holds, but science is a really good way to understand what's happening in the world. It's a tool we use. It's a lot of fun. And, you know, I get to be outdoors, I get to travel and see different parts of the world, and I get to work with different kinds of people. And it's really exciting. And I hope that if you feel that excitement when you go outside and look at the world and have a question about it, because it's really one of the best ways to get answers to your questions. And I hope to see some future scientists out there.
Well, thank you. That's unfortunately all the time we have for today. I'd like to say thank you again to our live stream viewers and our 2 classes in Iqaluit, Nunavut and Guelph, Ontario, and to Dr. John Gamon for taking the time to answer our questions and share his expertise with us. So thank you for joining us today. I hope everyone enjoyed today's event. To see what's coming up on the PIR live events website at www.pirweb.org or follow us on Twitter @PartnersInRes. Have a wonderful day and goodbye, everybody.